Hello, I welcome you all. The problem reads a toboggan having a mass of 10 kg starts from rest at A and carries a girl and a boy having a mass of 40 kg and 45 kg respectively. When the toboggan reaches the bottom of the slope at B, the boy is pushed off from the back with a horizontal velocity of 2 meters per second measured relatively to the toboggan. Determine the velocity of the toboggan afterwards. Neglect friction in the calculation. So this problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. So we are going to call this as our state 1. We'll call this as our state 2. And we'll call this as our state 3. Okay. So we have 3 states. 1, 2, up to 3. Okay. Of course, we are going to apply the conservation of momentum at this particular point here. Okay, so from A to B, we can find the velocity. All right, and from B to 3, we can find the velocity of the toboggan and the boy. Let's do that. So say using the conservation of mechanical energy. So say our T1 plus V1 is equal to T2 plus V2, where T itself is the kinetic energy and V is elastic, gravitational, and elastic potential energy, where Vg is just equal to Wh and Ve is just equal to half K, the spring's constant squared. All right, so let's start. So at A, we are going to just say MT plus MG for girl plus MB for boy, okay, at A. All right, so let's call this as our VA or V1. All right, okay, that's at state 1 and plus nothing at state 1. Sorry, we are using the conservation of energy. Sorry, so it is half M total. So this total is MT plus MB plus MG girl plus MB, and we'll call this VA squared at state 1. Okay, can just remove that. Then we know that the two are just going to be, potential energy. We have W, WT plus WG plus WB times HA. Okay, if this is our datum, this is our datum, this is our datum. Okay, all right, plus this part VE itself is just equal to 0. All right, VE1. Okay, we're in the first state, so we can put these ones if you don't mind. then this is equal to at this stage here we have half again, mt plus mg plus mb vb squared is state 2 plus wt plus wg plus wb hb2 and ve2. Of course this part is 0. Okay, this part is 0. Okay, which other parts are zeros? This part is also 0, and therefore what we only have is this. So say 10 plus 40 plus 45 by 9.81 by the height, which is just a 3, and this is equal to half 10 plus 40 plus 45 by VB squared. Okay, this is in state 2. That's all right. The rest, this is also 0. Okay, and therefore VB2 is just going to be equal to what do we have? Of course, we can cancel out the rest, dot and dot, and all we can say is 9.81 by 3, and then we can divide this by 0.5, then root of that. So we have a 7.6720. Okay, so this is VB2 here. So once we found VB2 here, so found VB here, then we are going to apply at this particular instant momentum. So say using the conservation of momentum. Okay, so say summation of mi vi in state 2 is just equal to summation of mi's vi's in state 2, state 3. What do we have? So we do have, in this particular state before the boy falls down, so we do have 10 plus 40 plus 45. Okay, I can write the whole equation. Maybe. So I'll say mt plus mg for girl plus mb for boy, and then we'll say vb2. Okay, this is going to be equal to mt plus mg. Okay, this we are going to call it v3 plus mb vb3. Right, let's plug in the numbers. So once we add this together, this becomes 40, 15, 45, that is 95 kg by 7.6720, 67 This is 7.6720. This is equal to, we add the 2, which is just a 10 plus 40 by V3, then plus 45 by 45 by VB3. We've been told that this boy is pushed back with a velocity of 2 meters per second relative to the toboggan. So this is in the other direction. So therefore, we are going to say VB stroke T is equal to VB minus VT, and this we're saying in step 3, and this is equal to minus 2 because of the direction. The minus is because of the direction, okay? Because we are saying this is our reference, this is our reference, okay? So this is our reference. All right, so this is our y, this is our y, this is our x, right? And therefore, and in our case here, our VT3 here is just equal to V3, okay? Therefore, we can write this as our VB3 is just going to be equal to VT, V3 minus 2. Is that okay? Right, so let's plug in this value here. Let's plug in this value here. You plug it in there. When we do so, then we can calculate what V3 is. We can say the V3 is just going to be equal to, you can grab your calculators. So we have 95 times 7.6720 minus no plus 45 times 2, all right, and then we'll say divided by 50 plus 50 plus 45, okay, and then this gives us 8.6194. This is meters per second, and this one is in this direction. This is the toboggan, okay. This is toboggan plus the gap, okay. All right, so let's find our VB3, okay. You can find it either using this equation here or using this equation here. Should still come back to the same thing, okay. That's V3 itself minus 2 gives us a 6.61, okay, 6.6194, okay, and this one is in this direction here. This is just a boy only. So let me check it out with that equation. So we have 95 by 7.6720 minus 50 times B3 8.6194 divided by 45. Okay, I think this is about it. We have found the speed of the toboggan and the girl. We've also found the velocity of the ball as well. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.